Ever looked at a street photo and wondered, what's the exact address here? You're not alone. Even smart AI systems struggle with this, until now. Today, we're talking about AddressVLM, a breakthrough model that's rewriting the rules of how AI understands street addresses. Let's break it down. Here's the problem. Traditional AI can guess a city or country from a photo, but pinpointing a specific street. That's a whole different ballgame. Think of it like trying to find a needle in a haystack, except the haystack is a blurry, confusing street view, and the needle is a single address. Existing models just can't see the forest for the trees. So how do we teach AI to spot the exact street in a photo? The answer lies in cross-view alignment, a fancy way of saying, let's use two different perspectives to get the full picture. Imagine you're lost in a city. You'd check a map for the big picture, and then look for street signs for details. AddressVLM does the same, but with satellite images and street view photos. Here's how it works. The model first learns to align satellite maps with street-level images. It's like teaching a robot to match a puzzle piece to its spot on a map. Then it's fine-tuned to answer questions like, is this photo on Fifth Avenue? Or what street is this? To train it, researchers created special datasets. Think of them as giant photo albums of Pittsburgh and San Francisco, filled with thousands of street images and address clues. The results? AddressVLM crushes the competition. It's 9% to 12% more accurate than older models, which is like upgrading from a basic calculator to a supercomputer. But here's the real win. It doesn't just guess. It understands context. If you ask, where was this photo taken? It might say, the curved glass building and red brick houses match the map's layout near Forbes Avenue. That's the power of combining big picture maps with close-up details. Think of a delivery driver trying to find a house in a foggy neighborhood. A regular AI might say, this looks like downtown, but AddressVLM could pinpoint the exact street, even if the house number is hidden. Or imagine a tourist asking, what's the name of this street? The model could answer with confidence, using clues from both the satellite map and the street view. But how did they make this possible? The team behind AddressVLM cracked the code by tweaking a technique called temperature scaling. Imagine it as a creativity knob for AI. By cranking it up during testing, from 0.1 to 0.8, the model generates more varied answers. Then they ran the same image through the model 100 times. The result? A map of possible street names, showing how the AI thinks about the input. This helped them spot patterns and understand where the model was confident or confused. But even that wasn't enough. So they tried a zero-shot approach, giving the model a list of possible street names and letting it pick the best one. It's like handing someone a multiple-choice test, instead of asking them to write an essay. And guess what? This simple shift made the model way more accurate, especially for tricky cases where the photo was unclear. The real test. Comparing AddressVLM to other top models. While others gave wild, inconsistent answers, sometimes repeating the same street name over and over, AddressVLM stayed reliable. By averaging the most common results from multiple runs, it balanced creativity with precision. And the data backs this up. In experiments, AddressVLM outperformed competitors across key metrics. This isn't just a clever trick. It's a breakthrough for navigation apps, geolocation tech, and even disaster response, where pinpointing locations matters. Next time you use a map app, remember, behind the scenes, AI is working hard to turn blurry photos into precise addresses. Innovations like AddressVLM are making that process smarter, one street at a time. Thanks for watching. If you want to explore more about AI's real-world magic, hit subscribe. And drop a comment, what's your favorite tech hack that makes life easier? Until next time, stay curious.